Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and today we are specifically going to look at Venn diagrams. Now, we have looked at Venn diagrams so far in the other videos, but more as using it as an explanation. So this video is specifically going to look at Venn diagrams and how it is more often than not going to be asked in exams. So what I'm going to give you as a task is to go and draw this Venn diagram and answer the question of how many drank all three. So hit the pause button and try this video yourself, or try the sum yourself, and then you hit the play button to see the rest of the video. First of all, how do I know that it is a Venn diagram? Remember, we've got three options in grade 11. We have tree diagrams where there are multiple events happening after one another. Venn diagrams, which are there for when we have more than one choice, or there is contingency tables, which has to do with independence. Now, obviously, this is a video about Venn diagrams, but in the exam, you are not going to necessarily be told that. So when we look at this, there's more than one choice. So my choice is going towards Venn diagrams. So I'm going to draw a Venn diagram with three different circles for my three different choices. And I know that there are 60 people, so I know N of S, the sample space, will be 60. There can also be a sample space that works with probabilities, like in the first video in this, in my series of videos. But this one specifically is talking about the number of things, not the probability of things happening, but the number of things. Let's now go and look at analyzing what they've been given. First of all, I've got coffee, tea, and Milo. I've got 40 people drinking coffee, 35 drinking tea, 12 people drinking Milo. I'm not going to touch that at the beginning. Where I am going to start is kind of jumping to the end, is I'm going to look for that middle where all three of them overlap. Did they give it to me? No. That's the actual question. So I'm going to substitute that with X. My bit of advice is always start in the middle. Start where all three overlap. If they don't give it, make it equal to X. Now let's go and look at the 6 people drinking Milo and coffee. So coffee and Milo, that's going to be where the C and the M overlaps. And that is then 6 minus X. Why is that? Just quickly, just so that you don't think that I'm pulling this out of a rabbit out of the hat. That's because those two together must give me 6. So therefore, that little one, which is only coffee and Milo, but not tea, is 6 minus X. So I'm going to do the same with the 20 people drinking coffee. So therefore, that little one there at the top is 20 minus X. And the 7 people drinking tea and Milo, and therefore, that is going to be that little piece there is 7 minus X. At this moment of time, all I'm going to do is fill in the rest of the Venn diagram. I'm going to start with the part in the C that is not overlapping. So I'm just going to call that little a. So I know all the pieces with that a. So that is the a with a circle in it. Okay, just to not confuse you. All of the circles inside the C must add up to 40. So that circled A with the 20 minus X, the X, and the 6 minus X must be 40. If I then solve that and get that A in the circle alone, it gives me 14 plus X. I'm going to repeat this process with a T. So therefore that little b plus all the other parts must add up to 35 because there's 35 people drinking tea, which means that circle B part is 8 minus x. Lastly, I'm going to call that C in a circle with all the Milo parts being adding up to 12. So that little c is x minus 1. If I fill that then into my Venn diagrams, my Venn diagram is going to look like that. Why do I do that? Because remember, I'm trying to solve x. I'm trying to solve that overlapping part. Now, I'm going to do a bit of a sneaky trick because all of the C parts, if I now just make some space, all of the C parts must add up to 40. Why? Because I know there's going to be 40 people that drink coffee. So that's my first start. So I'm going to say all of those parts in the C added up, plus, then I'm going to add up all the other parts in my Venn diagram. But now where does that 0 come from? Where? There's no 0 on the Venn diagram, but it's because we forgot to fill in that it says everyone drinks at least one of these drinks. So there's going to be 0 people that doesn't drink any of those drinks. Be careful. You've got to look at those parts outside of your Venn diagram, and all of them together must add up to 60 because that is your sample space. So when we look at now solving for x, I've got 54 plus x equal to 60, and therefore x must be 6. Simple as that. Does that now answer my question? Yes, that there are 6 people that drink all 3. But I'm going to take this now one step further. I'm going to now look at actually answering questions about this Venn diagram. So wherever there's an x, I want you to replace that 6. Go to your Venn diagram and replace that, which means your Venn diagram is now going to look like that. So here are 3 questions that I would like you to answer for me quickly. The probability of only Milo, the probability of at least 2 drinks, and the probability of not drinking Milo. Go for it, ladies and gents. If I look at this first question, what is the probability of only M? So in other words, not coffee, not tea, then that is that circled 5. Probability, so it's 5 out of 60 because there are 60 people in total, which gives me 1 over 12 as being my probability. Now, what about the probability of at least 2 drinks? So that is all of those 2 or more. So it's going to be wherever there's an overlapping in my circles there. Probability of 2, so I'm going to add all of those together and divide it again by 60 because I'm asking you for the probability. And last but not least, let's simplify that, which gives me 0.35, or you could have left it. Let me quickly do the maths there. I could divide both numerator and denominator by 3, which is then 7 over 20. Woo! The maths is strong today. What if I'm looking at the probability of not M? So that means outside of M. Well, what I could simply do is say 1 minus the probability of actually getting M. Because you're either going to drink Milo, or you're not going to drink Milo. So 1 minus the probability of drinking Milo. So in other words, 1 minus 12 over 60, which is 48 over 60, Simplified is 4 over 5. Ladies and gentlemen, as simple and as easy as this. I hope you enjoyed this video, and I hope you're going to go and practice a lot after this. You need to practice Venn diagrams and make sure that you are able to do this. This is Mr. VG signing out. Have a gorgeous, amazing rest of your day. I hope that you are going to ace these probability questions. Keep well. Cheers.